What we'll be doing today is we'll be going over the extraction of 3 wastewater samples on the Fluid Management System's TurboTrace ABN system. There's 3 synthetic wastewater samples, 1 liter each, prepared for the extraction of 625 EPA wastewater method for semi-volatile compounds. The system is a positive pressure solvent delivery vacuum sample loading system in which water samples will be passed across 2 cartridges in parallel, and then each cartridge will be eluted separately into 2 separate fractions. The first cartridge is a reverse phase ion exchange bed packing. The second cartridge, a 2-gram coconut charcoal cartridge. This will automate the EPA process of extracting samples at both acidic and basic pHs while loading the sample across the cartridge in one pass. The system's solvent delivery consists of 4 different solvents: a DI water matrix, a methanol, methylene chloride, and a 1% ammonium hydroxide in DI water solution for changing the pH of the cartridges. The first step in the method, as we prepare the samples, is we'll adjust the pH of the samples to less than 2. This will be done by adding a hydrochloric acid solution to the samples and then checking the pH of each bottle. Add the acid solution. We will now cap each bottle to make sure the acid is evenly distributed. We're just going to give it a light turn without shaking the sample. Shaking the sample could cause frothing, which would be undesirable for loading the sample. You can see in the sample as I prepare this, there's a fair amount of insoluble material in the wastewater samples. There is a surfactant which creates that emulsion-like frothing, as well as other soluble materials to synthesize all of the aspects of a live, real wastewater sample. We'll then pH the samples, make sure that they are indeed 2 or less for the pH. As the next step, we will then add our surrogate spiking solutions to these samples. This is an acetone solution containing both the acid and basic analytes. And we will add 1 ml of those solutions to each sample. Allow that to enter without any splashing or spilling. We will then apply the sample bottle caps, which consist of the sample tubing to draw the sample up to each bottle. And then with these lower fittings, attach the bottle cap to the instrument. Begin to power up the system. We will go into the touchscreen into the Run program, where we have a list of automated programs for different methods. We will select the 625 method and OK. And what we will do when we start it is we will go down a series of line-by-line steps in which all of the required procedures and steps for conditioning the cartridge, loading the samples, drying the cartridges, and eluting the samples will all be automated in a continuous process. As a quick overview of the system, as we pointed out the cartridges before, we have the solvent delivery pump along with the multiple solvent lines. We have a bubble sensor on each unit which will detect when each sequential sample is finished and stop each position from exceeding excess vacuum while the other samples load. And we have our multi-fraction collection vials which will separate both the acid and basic fractions from each other. So down there along with the sample bottles, we have 2 lines coming out and 1 going in. Next to each bottle is a small reservoir of methylene chloride, which after the sample is loaded will spray methylene chloride along the sample bottle walls, and then the other line will draw that methylene chloride up, adding it to the extract to cover both the bottle rinsing as well as the cartridge elution without any interaction from the analyst. So at this time I will start the program, and the program will initiate. The first step as it goes, it will prime each solvent as it prepares them, and it will go through a series of cartridge preconditioning steps. First, a methylene chloride conditioning step, followed by a methanol conditioning step, and then a water wetting to remove the methanol before the samples are loaded. In the top of the screen on this LED board is a small fluidic pathway in which it will show you the solvent it is pulling, where it is going across the pump, to the solid valve, to the cartridge, and to the waste vial. And these lights will illuminate and change as different steps of the program progress. See now as the methylene chloride starts to wet the cartridges, you can see the mixed bed cartridges beginning to wet. And in this step it will apply 10 mils of methylene chloride to each cartridge just as a pre-wetting cleaning step. You can see in the cartridge each mixed bed cartridge is fitted with a pre-filtration device in order to separate all of the particulate matter from clogging the cartridge. And we'll now begin to wet the second cartridge with the solvent. Following the cartridge wetting, there will be a brief nitrogen pulse of the cartridges to ensure all the methylene chloride is removed from the cartridges before the remaining conditioning steps continue. The other cartridge. Following which, the pump will now begin to exchange to methanol and continue with the remaining conditioning steps before sample loading. At this time, we're finishing up the cartridge conditioning, and we will be about to begin the sample loading with the vacuum pump. At this time, the sample valves open, the vacuum pump kicks on, and as the vacuum builds, sample begins to draw across the bubble sensors, and at which time they will go off until there is no more sample passing across them, and they will close the valves to terminate sample loading. As we progress through the sample loading, you can see at this time we are about 1/3 of the way through the sample loading, and across all three bottles you can see we are achieving a very linear sample loading rate for all the samples. And as the sample loading begins to finish, you can see we're getting down to the final mils of the sample. Pretty much a fairly linear sample loading still, even after almost an entire liter of sample. You can see we're also starting to begin to draw up all of that sedimented particles onto the cartridge. And then once those last volumes are drawn up, we'll begin to terminate the loading for individual modules. Now we're finishing up the sample loading. You can see all the sample bottles reaching their end line, and then momentarily the valves will begin to turn off as bubbles from air pass across the sensors. We need to draw the air as the sample is finishing. Sample 1 is closed. Once the last sample finishes the remaining volume, the program will proceed to the next step. And here we go, the bubble sensor tripping and sealed. There's a remaining step where the last of the vacuum will be released and the lines vacuum dried before we enter a stage of solvent exchange, and then begin the bottle rinse and cartridge elution. And at this time, after the vacuum is released and all the samples are loading, there is a brief nitrogen drying of the cartridges just to remove any residual water before the elution steps. This is a very short step, as you do not want to risk over drying cartridges and losing some of your more volatile analytes, but you do want to limit the amount of water exposure to ensure you get a good elution of all compounds bound on the solvent beds. And after a brief solvent exchange of the pump, we'll then spray the bottles and rinse all the sides and the particles with methylene chloride. And you can see the methylene chloride spray rinsing the bottles, after which it'll then be drawn back up and eluted across the cartridge and collected in the fraction vials. Now we've begun drawing that up. And simultaneously eluting the cartridges. Whereas fractions are solvent is being collected in the acid fraction vial. After all these sample rinse is drawn up, it'll then follow up with an additional rinse of methylene chloride across the mixed bed cartridge to ensure that no analytes are left behind from the bottle rinse. And that again will be collected in the acid vials. At the end of the cartridge elution, there will be a brief nitrogen push to push all the remaining fraction solvent to the acid vial before we begin re-exchanging the cartridges for the elution of the basic compounds. And here is the nitrogen purge of the cartridges to capture the remaining solvent in the lines and on the cartridge bed. And this will deliver a total acid fraction volume of approximately 35 mils. of methylene chloride. And at this time the acid fraction is collected. I've simply turned the vial so we can see the basic vials as we collect, and we've begun re-exchanging the cartridges and converting the pH to a basic pH 12 before we elute the cartridges for the second fraction. The first step of which is the cartridges will be re-exchanged with methanol to remove any residual methylene chloride, and then a ammonium hydroxide solution will be passed across the cartridges to convert the pH. As we finish up the pH exchanging with the ammonium hydroxide, once both cartridges are exchanged, it'll then go into a brief nitrogen purge, as it did after loading the sample, to remove all the residual ammonium hydroxide water solution from the cartridges, and then elute them into the basic fraction. So there'll be a brief nitrogen dry of each cartridge, just 1 minute each side, and then it will elute. And now the other cartridge will nitrogen dry for 1 minute as well. And now it's beginning the elution of the cartridges. It's going to elute first the coconut charcoal cartridge. This will be at a slightly slower flow rate, 5 mils a minute versus 10, just to increase the DCM contact time on the coconut charcoal to ensure that you get a good smooth elution of the analytes bound to it. You can see the methylene chloride working its way through and then collecting in the vial as it reaches full saturation. And it'll now begin eluting the mixed bed cartridge, again with methylene chloride, and adding it to fraction 2. Here's the methylene chloride beginning to introduce, and then again combining to the same vial as the coconut charcoal. After elution, it'll purge each one again with nitrogen as it did in the first elution, and empty it into the same vial. So after 20 mils of elution, it'll now do the nitrogen purge of the mixed bed, followed by the coconut charcoal cartridge, and fraction 2 for basic compounds will be complete. And for fraction 2, there will be a total combined volume of approximately 45 mils as compared to 35 mils for the acid fraction, bringing the complete extract to approximately 90 mils for the entire 625 sample. And now the second cartridge.